Hello, I'm Hein, and I will start this week's review. Last week, we talked about the basic concept and the three states of the MOSCAP, and today I will talk about the characteristics about MOSCAP. Uh, if you apply a bias, the MOSCAP in the MOSCAP, the total charge density are changed because to react the change of the bias, the carriers in the body come to the surface of the MOSCAP. So we can draw the graph of the total charge density of the MOSCAP like this. But uh, it's not enough. As I mentioned before, we can explain the MOSCAP as capacitors because it has a insulator, the oxide in the middle, and the carriers, the charge, gather both sides of the insulator. So we can explain the MOSCAP as a MOSCAP as a capacitor like this. Uh, when we apply the uh, reverse bias, the minus bias on the MOSCAP, it becomes the state of assume accumulation, and when we bias the negative bias on the gate, it makes the depletion or the inversion state. So when we apply the negative bias on the MOSCAP, the first capacitor of the MOSCAP is the COX, and the depletion region makes the other capacitor of the MOSCAP. So we can explain the two type of capacitor as a series form. In these situations, uh, according the role of the summation of capacitance, the the capacitances become more or less than when the COX only exists. But when we apply more strong bias in this, the charges gather in the surface, so the depletion width becomes more smaller and the capacitance becomes more big, so it the total capacitance more bigger than ever, and in the strong reversion it becomes equal to the COX. Like this, we can control the capacitance of the MOSCAP with the bias which we apply in the gate. Next week, I will explain of the MOSFET, and the MOSFET is the very similar element with the MOSCAP. It's the simple figure of the MOSFET, and MOSFET is the elements when we add some source and drain in the body of the MOSCAP. So let's talk about the MOSFET in the next week. Thank you.